Hello everybody, welcome back to Channel ANZ Machinery. Steel wire ropes are indispensable in industries requiring robust, high-strength materials, from construction and mining to maritime and transportation. The process of manufacturing these braided wire ropes involves a blend of craftsmanship, precision engineering, and advanced technology. This article takes you through the intricate steps, from raw materials like hemp tar to the final product, as well as the state-of-the-art equipment used in the production process. The journey begins with hemp tar, which serves as a protective lubricant for the wire strands during the braiding process. Steel wire, the primary material, is procured in its raw form, often sourced from carefully selected suppliers worldwide. These wires undergo rigorous quality control to ensure uniformity in diameter and tensile strength. To prepare the wires, they are drawn through a series of dies to achieve the desired thickness, creating high-strength steel strands. Each strand is coated with a thin layer of hemp tar, which acts as a natural lubricant to reduce friction and enhance the longevity of the finished rope. The braided wire rope is formed by twisting multiple strands of steel wire into helical patterns. This step combines mechanical precision with human oversight to ensure consistency in strength and flexibility. Wire braiding machines play a critical role here. These machines interweave individual strands under tension, forming a uniform rope. Depending on the application, the ropes may consist of 6, 8, or more strands twisted around a central core. The central core, often made of steel or fiber, adds flexibility and cushioning, enabling the rope to endure heavy loads without deforming. A pivotal part of the production process involves hydraulic pressing, using tools like the SOM Splice 6000 kN hydraulic press. This powerful single-column press can handle steel wire ropes up to 38 mm, 1.5 inches in diameter. Compressing and bonding. It compresses the strands into a single cohesive structure, ensuring durability and reliability. Splicing. The press also facilitates splicing operations, where 2 or more ropes are joined seamlessly for extended applications. Manufactured according to DIN and ISO 9001-2000 standards and tested for N693 and N982 compliance, this equipment ensures precision and safety throughout the process. The annealing process softens the steel, improving its ductility and making it easier to work with during subsequent steps. Steel cables undergo controlled heating and cooling cycles to enhance their tensile strength and corrosion resistance.
Next,
Cable slitting is performed using advanced machinery like the SOM splice slitters and slicers. These tools, such as the 1224, 1225, and 1226 models, are designed to separate cables into manageable ends for further processing. They can handle cables with diameters ranging from The slitting process also involves flattening the cable ends into a conical shape, enabling better integration in applications requiring high load-bearing capacities. Once the individual strands and sections are prepared, the final assembly phase begins. At this stage, bespoke steel cables measuring 61 meters by 0.36 meters are crafted to meet specific client requirements. The assembly process combines craftsmanship with precision machining to ensure tight tolerances and high-quality finishes. Throughout production, stringent quality checks are carried out to monitor parameters such as tensile strength, flexibility, and resistance to environmental factors like corrosion and abrasion. These checks are vital for maintaining the reliability of wire ropes used in critical applications. Producing steel wire ropes involves tight control of the supply chain. Raw materials, primarily sourced from Asia, are delivered just in time (JIT) to reduce storage costs and ensure production timelines are met. This synchronized approach enables manufacturers to meet custom orders with precision while minimizing delays. Crafting a 4-strand rope from tarred hemp. In the heart of Alvängen, Sweden, renowned ropemaker Sarah and her apprentice Niklas joined forces with Bernt from the Rope-Making Museum to create a magnificent 4-strand rope. The historic rope walk in Alvängen, longer and more advanced than the one in Hardanger, provided the perfect setting for their task, weaving a sturdy rope from tarred hemp to secure the historic ship Garine in Hardanger. The process began with selecting high-quality tarred hemp, known for its durability and resistance to water. The fibers were carefully aligned and twisted into strands using specialized tools. Unlike simpler rope walks, the one in Alvängen allowed for greater precision in crafting longer, thicker ropes. Each of the 4 strands was twisted evenly to ensure uniform strength and balance. Sarah, with her seasoned expertise, demonstrated how to maintain consistent tension while twisting, a critical skill for ensuring the rope's durability. Niklas, eager to learn, diligently assisted in feeding the strands through the rope-making machinery. Bernt, a historian of the craft, shared insights into traditional techniques, enriching the experience with anecdotes about rope-making's maritime heritage. Once the strands were ready, they were laid together in a precise pattern and twisted into a single robust rope. The final product was a testament to teamwork, tradition, and skill, a rope strong enough to withstand the harsh maritime conditions Garine would face. As they packed up, the trio admired their handiwork, knowing their craft was preserving a piece of history. The rope walk in Alvangen had proven its worth, enabling the creation of a rope as enduring as the stories it would help secure.